Okay, good afternoon all. Please confirm that my present slides are visible because I was not able to see it on my screen. Pranay, are you there? Pranay or Prajwal? Please
Yes, sir,
confirm
visible.
that
Yes,
visible.
sir,
No?
screen is
Okay. Then we will start. Okay. Uh, okay. From last lecture, last few lectures, we are discussing related to non-destructive testing methods and destructive testing methods. We have started with the concept of destructive testing methods, then non-destructive testing method. And from that, we have already started the destructive testing method. And in that, we have finished the tensile testing method. In that, we have learned how the specimen preparation is done, how the test is conducted, and which kind of the properties we will be able to determine at the end of that tensile test. Now, after discussing the tensile test, in today's session, we are going to deal with the impact test. In this same points we are going to discuss here. For which purpose we are going to perform this impact test, then how the specimen preparation is done, and how the actual test is conducted. Then there will be some factors which will affect the output of this test, and which kind of properties we are determining with the help of this test. Okay. And so now this is the impact test. So we will start this. At the start, you have to mention why we are conducting this impact test. Okay, in that you have to explain that sometimes ductile material. Okay, there will be two types of the material generally, ductile material and brittle material. And whenever we are conducting the tests on it, or we are using that particular materials component in the actual practice, the material may get failed during its service life. Okay, and sometimes a ductile material will fail in a brittle manner. Okay, ductile material will fail in a brittle manner, means whichever formation of the nature of the crack is there, that will be different. Now, to understand this, you should first understand that what will be the nature of the crack in case of ductile material, and what will be the nature of the cracks in case of the brittle material. Okay, generally in case of the brittle material, if it get failed during the service, brittle material will show you crack perpendicular to the whichever loading condition is there, perpendicular to that they will show you a flat surface. Okay, flat surface will be there, and crack will be perpendicular to the loading conditions. And in case of the ductile material, neck formation will take place, and cup and cone like surface will be formed. Okay, or you can say that wherever the crack formation is occurring at that point, if you see it from the top, you will be able to see two circles. Okay, means it is showing you the cup and cone appearance. And if you observe the brittle material, a flat surface will be there. In case of ductile material, nature of the cracks form will it will appear as a cup and cone surface or cup and cone finish. And for the brittle material, a flat surface will be there. In brittle material, flat surface, and in ductile material, and cup and cone shape will be formed due to formation of the neck. Okay, so sometimes the ductile material also fails by showing the nature of the crack very similar to the brittle materials. Then these conditions are, or these types of the failure, ductile material will fail in a brittle manner. This is happening due to the three parameters or three different conditions. In the first condition will be, if suppose whichever material you are using or component you are using, it is working at a very low temperature. Okay, if it is working at a very low temperature, then a ductile material may get failed in a brittle manner. Then second condition is very high rate of loading. If very suddenly high load is applied on the ductile material, it may get failed in a brittle manner. And third condition is triaxial state of stress. Okay, triaxial state of stress. Then what is the meaning of triaxial state of stress? Triaxial state of stress means here on that material only normal stresses will act. There will not be any shear stress. Only normal stresses will be there, and all shear stress values will be equal to zero. That condition will be termed as triaxial state of stress. Okay, so if any of these conditions are present, any of the these means following three conditions may be there, or I will repeat it again: a ductile material may fail in a brittle manner due to following three conditions. First conditions will be lower working temperature, and second condition is the high rate of loading, and third condition is triaxial state of stress. Triaxial state of stress means at a particular point or at a particular location in that material, only normal stresses will be there. No shear stress is present, or all shear stress values are zero. That condition will be termed as triaxial state of stress. And if any one of these conditions is present, there may be any one condition or combination of one or more conditions will be there. There may be, suppose, working at low temperature, or there may be only triaxial stresses, or there may be a rapid rate of or faster rate of loading may be there, or combination of all these. Okay, it will result in the brittle failure of a ductile material. Okay. So, to determine these conditions or to determine the failure or failure point of that particular material, you have to conduct the impact test on that material. Okay, by conducting the impact test, we will get certain values, and that values will be nothing but the capacity of that material, or you can say that amount of energy that material can absorb, or in other words you can say that here we are going to determine the toughness of that material, amount of energy that material can absorb before its fracture or before its failure, and that is known as the toughness, and it can be determined by conducting the impact test. Okay, and during this impact test, the ductile material will fail in a brittle manner, and to determine these values we are going to create certain conditions we are going to create, so that that material, ductile material, will get failed in a brittle manner. Okay, and which conditions we are going to create, or which will be the our test conditions, whichever three parameters, whatever three parameters we have discussed: low temperatures, then high rate of loading, and triaxial state of stresses. These conditions we are going to create on the our test specimen, and we are going to conduct a test with the by creating these three conditions there, and we are going to determine the capacity of that material to absorb the energy before the actual fracture, and that will be termed as the toughness. Okay, here simply we are going to determine the toughness value. Here we will get a toughness value, or in other words you can say that the impact resistance. The as we here we are going to create a sudden loading or sudden impact on that material, you will also get the impact resistance value for that material. Okay, now how to conduct this test? For conducting, okay, this is the just the introductory part, why we are going to conduct this test, or what is the importance of the impact testing. Okay, already these points you have to write in simple way. You have to write like this: a ductile material may get failed in a brittle manner due to its capacity, or due to low absorption of the energy, and this low absorption of energy is due to following three conditions: low working temperature, then a high rate of loading, and triaxial state of stress. And during this impact testing, what we are going to do here, we are going to create these kind of all these three conditions in the test specimen, and we are going to determine its actual capacity or amount of energy that material can absorb before its failure, by creating all these three conditions, that is triaxial state of stress, and low working temperature and rapid loading. Here rapid loading is nothing but a impact, sudden or fast load will be applied in this test, and we will going to determine its toughness. Indirectly we are going to determine its toughness, or you can say that the impact resistance of that material. Now how we are going to conduct the tests? Here we are having two types of the tests. Okay, the first test is the Charpy test. Okay, um, first test will be the Charpy test, and second test will be the Izod test. These are termed as Charpy impact test and Izod impact tests. Now, this Charpy impact test, this is used in the United States, and Izod impact test, these tests are generally used in the Great Britain. Okay, now you can use any test depending on the material. Means for different materials, you can use this. Both tests can be conducted. Just you have to prepare the specimen in the different ways. Okay, specimen preparation will be different in both the tests. This is Charpy impact test and Izod impact test. In Charpy impact test, specimen preparation will be in different way, and in Izod impact test, specimen preparation will be in the different way. Now, before going means before starting the actual conduction of the test, first you should understand that how the specimen is created, or how the specimen preparation is done for Charpy impact test and Izod impact test. Only these things will be different. That is the specimen preparation will be different in both the tests, and what the actual procedure to conduct the test will be same. Procedure will be same. Just what is the difference between this Charpy and Izod impact test is the preparation, test specimen preparation will be different. Now first we will start with the Charpy impact test. Okay, you can draw if any specifically they have asked you the Charpy impact test, then uh, you can draw this diagram only. Means the same diagram you can draw for both tests, and depending on the test asked, you have to draw the specimen preparations diagram. Then first we will discuss about the Charpy impact test. Okay, now this is the specimen preparation. Okay, specimen preparation for the Charpy impact test. Now in this Charpy impact test, this you can use three different kinds of the specimens can be used. Now the dimensions, or you can say that whichever notch used is different types here. Okay, in Charpy impact test, three types of the notches can be made, and depending on that three types of the notches, that three types of specimens are available. And before discussing that notch, dimensions of the notch, we will discuss the dimensions. Here, this Charpy impacted specimen will be a specimen having square cross section. You can see that this is the square cross section. It will be having the length will be 55 millimeter, and its you can say that thickness and width is 10 millimeter. Okay, 10 millimeter thickness and 10 millimeter width will be there, and length is 55 millimeter, and exactly at the center notch is created. Now why notch is created here? This is very important point in this impact test. Why notch is created? Now in this impact test we are going to create the three different conditions. Now the first condition will be creation of a triaxial state of stress. Now that triaxial state of stress is created by preparing a notch. Okay, notch is prepared. Okay, this is the V-shaped notch. V-shaped notch, and its depth is 2 millimeter. Up to 2 millimeter depth, that V-shaped notch is prepared. So this is the specimen with a V notch. Then you can use a keyhole notch also. Keyhole notch, it will be approximately 5 millimeter in depth, and it is having a hole of 2 millimeter diameter. Then this will be a specimen with keyhole notch. And the third is specimen with U-shaped notch. And if U-shaped notch is used, its maximum depth is 5 millimeter. or 5 millimeter depth will be there for that U-shaped notch, and exactly at the center of that specimen that notch will be created. In all these three types of the specimen prepared in the Charpy test, you can prepare a specimen with V notch, keyhole notch, or a U notch. Exactly at the center it will be notch will be created, and with the help of this notch we are creating the triaxial state of stress here. Due to this notch preparation at this particular point, only normal stresses will act on that material. There will not be any shear stress. All shear stress values will be zero at this particular point. So this is the notch preparation. And whenever you are now at the end of this test, this material will get failed. Here you are going to determine the brittle failure with the help of the notch. That's why this test, you will end up with getting this procedure is termed as the determining the notch sensitivity. Okay, sometimes they may ask you in the objective questions, which type of sensitivity is measured in the impact test. Your answer will be notch sensitivity we are measuring here. And with the help of that notch you may use V-shaped notch, U-shaped notch, or keyhole notch. And with the help of that notch, here we are creating the triaxial state of stress. Okay, this is the triaxial state of stress. These conditions we are preparing here. Then this is the preparation of the specimen for Charpy test. Now this specimen preparation for Izod impact test. This will be your specimen again here. Square cross section, you can say that, or a square prism we are using simply here, having 10 millimeter thickness and 10 millimeter width, and its length will be 75 millimeter. And in this Izod impact test, V notch, only a single type of notch is used here. In sharp impact test, three types of notch are used depending on the material, type of the material. And here we are using only a single, means you can say that only a V-shaped notch is used here. And this notch is prepared, or it is created from one side or one corner 47 millimeter, at the length of 47 millimeter, or from one corner it will be away from one corner at a 47 millimeter distance. This V-shaped notch is created having 2 millimeter depth, having 2 millimeter depth. Okay, its dimensions will be 10 millimeter thickness, 10 millimeter you can say that its width, and 75 millimeter will be length. And the notch will be present at a distance from one corner it will be 47 millimeter, and from another corner 28 millimeter. Okay, in this way this test is specimen is prepared for conducting Izod impact test and Charpy impact test. Okay, in the Izod and in Charpy impact test, these are the differences. Okay, you can say that differences in the dimension. In Charpy impact test, now this space dimension of the specimen will be 10 by 10, that is 10 thickness, 10 millimeter width, and 55 millimeter length. These are the differences I am telling you. In and in the Izod impact testing, test specimen will be 10 millimeter thick, 10 millimeter width will be there, but length will be more, 75 millimeter. And in Charpy impact test, here you can clearly see that the notch is present exactly at the center. And you can use three types of the notches: V, keyhole, and U notch you can use here. But in Izod impact test, only one type of notch, that is V notch, is used, and it is not present exactly at the center. It is away from one corner by 47 millimeter distance, or you can say that 28 millimeter from one corner. And one more very important difference in the Charpy and in the Izod impact test, whichever impact will be there, okay, whichever impact loading will be there, in case of Charpy test, that impact will be in the opposite, or impact will be on the opposite side to the notch. Okay, notch and impact direction will be opposite. Notch will be on this side and impact will it will occur at the opposite side. And in case of Izod test, the impact will be on the side where notch is present. Okay. This is the difference. These are three, four differences related to its length, then types of the notch used, then present location of the notch, and impact loading, direction of the impact loading. In the Charpy test, its direction, striking direction will be opposite to the notch, and in case of IVOD, it will be in the same side. Okay, now we will move towards the actual. Now we will move towards the actual test procedure. Okay, if you are having any difficulty in the test specimen preparation, then you can ask me. Otherwise, we will move towards the actual test procedure. Please mention your queries in the chat box, or if all points are clear, I will move forward. Okay, notches can be prepared by simply you can do one machining operation. Okay, you can use different machining operations, and simply that notches are prepared. Sometimes you can also use your different that cutters are also available. With the help of that cutters, also you can make that notches. Any other queries there? Okay, then we will start the actual test, how the test is conducted. Now, this is the arrangement for this test. You can say that this is the impact testing machine, or in some books, it is also termed as a pendulum impact machine. Now, pendulum, it is consists of a hammer, and it is also known as a pendulum. Okay, it is also known as a pendulum. Okay, now I will first you have to draw this diagram. Then after drawing this diagram, you have to mention the constructional details. Now here it will be having a base or support. Okay, this is the base or support. You can say that. Then there will be a support or a platform to adjust or fix the specimen. It will be termed as anvil. Okay, one solid portion will be there, and here you can fix your specimen. This will be termed as the anvil. Then there will be a pendulum, or in other words you can say that a hammer. It is a hammer, and it is having a tub. You can say that a tub or a weight at the one end. Okay, here weight will be there, and this type of approximately shape will be there for that tub. Now, and this weight of the tub will be different. Okay, now here one concept is there. You have to understand that depending on the material under test, you can use different weight pendulums. Okay, there is no fixed weight of this hammer, or you can say that this is the tub used. This you have to change the hammers depending on the materials. Okay, there will be different types of the impact testing machines having different weighted hammers. Okay, weight of the hammer may be different depending on the requirement of that force to break that material. You can use the different types of the hammers. Here different types of the hammers in the sense you can use the hammers having different weights. Okay, different weight hammers can be used depending on the materials you are using, and you can use different heights also. Okay, here in this test we are going to release this hammer from a certain position. Then depending on the material under the test, you can change this height, and you can also change this weight. Okay, weight of this hammer or this hammer can be changed. This top portion or this corner portion, this is termed as the tub. Okay, this is termed as the tub. You can use different tubs having different weights, and you can release it from the different heights to change the impact conditions. Okay, to change the impact conditions, you can change these weights. Okay, now whichever in your books, that VD Kodgere book, suppose you are referring that book, in that book they have mentioned or they have calculated some velocity, means that critical velocity calculations are done there, and that calculations are done by assuming certain machine, one machine they have considered, one impact testing machine they have considered, and they have assumed certain weight of this stuff and a particular height, and depending on this weight and this height they have calculated the critical velocity. And whichever striking velocity of hammer, it should be, yes, sorry for disturbance, whichever striking velocity is there, whichever striking velocity of this hammer is there, striking velocity of this hammer is there, it will be calculated by using a simple formula, and that formula will be like this. Okay, here at the initial position, okay, initially it will be, you can say that this is the starting position of the hammer, and when this hammer is not in motion, then it will be having certain potential energy. Okay, potential energy of this stuff before the release, or you can say that the potential energy at the initial position or starting position, it will be calculated by using a simple formula, that is um, mgh. Okay, mgh in the sense it's mass of this stuff, then g will be gravitational acceleration, and h will be the height. Okay, this height, from this height we are releasing this hammer, mgh. By this simple formula we can calculate the potential energy of this stuff, and this potential energy will be equal to kinetic energy when you are releasing that hammer, and it will get applied, it will get impacted or struck on that material. Then at this particular position you have to determine its kinetic energy of that tub using the formula. Now kinetic energy will be determined by mv square by 2. Okay, mv square by 2, that will be the kinetic energy, mv square by 2, and this will be the potential energy. Now the potential energy at the initial position, it will be equal to kinetic energy of that tub when it impacts on the specimen. Okay, are you getting this condition? The potential energy of this hammer or this tub will be equal to, this is the potential energy when it is in stable condition, some potential energy will be there, and that potential energy will be equal to kinetic energy which will be there due to its motion. Some kinetic energy will be there, and exactly at this location when it impacts on that specimen, its kinetic energy, that is mv square by 2, it will be equal to this potential energy, that is mgh. Okay, in short you will get a equation m, okay, sorry for this disturbance, mv square by 2, it will be equal to mgh. Okay, Now it will be better if you write on the paper mv square by 2, it will be equal to mgh, and mass will get cancelled from both sides, and you will be able to get the value of v, and that value of v is nothing but the critical velocity. And whichever striking velocity you are using, the striking velocity should be lesser than this critical velocity. Okay, you have to consider, or you have to take care that whichever initially you have to calculate the critical velocity, and whichever striking velocity you are using, it should be always lesser than that critical velocity. Striking velocity of this hammer should be less than the critical velocity. Which is the critical velocity? The condition you have, that critical velocity value will be this potential energy of the hammer when it is at the rest condition, and the kinetic energy when it impacts on the specimen, it will be equal. At that particular condition, v will be calculated, and that v is nothing but the critical velocity. And always the striking velocity you have to keep it below that critical velocity value. Okay, so this is the initial conditions for determining its velocities. Now these are I will come to the procedure part. Now this impact testing machine consists of, I have already explained, base is there, then one anvil is there. Anvil will act as a platform to fix the test specimen. Then one hammer will be there having one tub, and you can change this, use different hammers or different tubs having different weights depending on the impact load needed. You can change the weight of this hammer, or you can also add, use the different heights according to the material used. Then at the top surface there will be a semicircular scale having one pointer. Okay, semicircular scale will be there, and one pointer will be there. At the end of that test, with the help of this scale and this pointer, you will get one toughness value. Okay, you will get one toughness value from this scale. Now, how the actual test is conducted, this is related to the constructional details. Now, how the test is conducted, depending on the type of the test, Charpy test or Izod impact test specimen is prepared with the required notch and required specified dimensions, or the standard dimensions required for that particular test, and the specimen is fixed according to the type of that test. Suppose if you are using the sharp impact test, the notch will be placed in the opposite direction to the strike. From this side, this impact will come, okay, from this side. And if Charpy test you are using, then notch will be kept in the opposite direction. And if you are using the Izod impact test, then this notch will be on the same side from which striking will be there. Okay, from this side, this is the striking direction. This is the striking direction. In Izod, notch will be on the same side, and in the Charpy, notch will be on the opposite side to the striking direction. Now, initially, your pendulum will be here. First, you have to fix this specimen here, and depending on the type of the test used, Charpy or Izod, its dimensions, then respective notches, and its respective positions you have to create here. And after that, you have to hold this hammer in this initial condition. Then you have to take the measurements of this mass. Then you have to take the measurement of the initial height. This is the initial height of the pendulum or a hammer. Then after fixing this test specimen, and after taking the values for the weight of the hammer and its initial height, this hammer is released. Suddenly you have to release it, and it will get impacted on this test specimen, and it will create one swing of hammer will be there. After impacting on that test specimen, it will move towards a certain, travel certain distance, and at that particular distance you have to mark this distance. Okay, it's which you can say that this is the starting position, and here this is the swing position of the hammer, and here also you have to mark its height. height of that tub, and it is also measured. Okay, this is the h dash. This h is initial height of the hammer, and this h dash is the swing height of the hammer. H dash is the swing height of the hammer. Weight will be same, just initial height and swing height you have to take the readings, and for corresponding to that swing height you have to means certain reading from that scale you have to take, and now how to calculate the actual toughness value that I have taken this is the diagram. This is the diagram from that VD. So sorry, these are the calculations done with the help of that. I have collected this from VD categories book. You can refer that. This is the initial energy of the pendulum. Initial energy of the pendulum means at the starting position. This is the initial energy of the pendulum. It will be mgh. M will be mass of this stuff, g will be gravitational acceleration, and h will be the initial height. And this we can say that the this is the here swing energy of the pendulum. This is initial energy, and the swing energy will be mgh dash. Mass of pendulum, gravitational acceleration, and h dash is the swing height of that pendulum. And if you take the difference between these two values, initial energy of pendulum and swing energy of the pendulum, if you take the difference, this mgh minus mgh dash, then you will get the toughness value, that is the energy required to fracture the specimen. Energy required to fracture the specimen, toughness value you are getting. Toughness value you can calculate here. It will be simply, this is the total weight of the pendulum, it is mass into gravitational acceleration and difference of the initial height and swing height. In this way you will get the toughness value from this test. So in the using this impact test, you are getting the toughness value, and this toughness value is nothing but energy material, maximum energy that material can absorb before its fracture or before its failure. That value you can determine in case in the form of toughness you will get here by conducting this impact testing. Okay, and in this way, this toughness value is calculated by conducting this impact test. Now, also with the help of that scale, whichever scale you have used, with the help of this scale also, you will get the toughness value. Okay, you will get the toughness value at this scale also. Okay, it will indicate the toughness value of that particular material. Okay, exactly where this impact causing at that particular, sorry for this noise, wait for 1 minute. Okay, by calculating this different calculations with the help of initial position of that hammer, final position of hammer, you can calculate the toughness, that is the energy that required for fracture of that particular material. And with the help of this scale also we will get the values of the toughness. Okay, now the last point for this test is certain factors, and certain factors are there or some variables are there which will affect this impact test. Now, already this factor I have discussed, that is the velocity of the striker. Velocity of striker is nothing but that velocity of the pendulum. Velocity of that striker should be always lesser than that critical velocity which we have calculated. Okay, it should be always lesser than that critical velocity. If that striking velocity or that striker's velocity is more, then it shows the wrong reading or it decreases the the impact resistance of that particular material. It will show that if more velocity is used, then it decreases, or it will show you the wrong readings of that impact resistance of that particular material. So this is the first factor. Then second factor is the dimensions of the specimen. You have to consider the dimensions of the specimen when you are using the standard specimens. Suppose you are using the standard specimens, and that specimen is showing you the ductile fracture. Then when the size of that specimen decreases, its impact resistance also decreases. Okay, there will be some impact of the dimensions also. If suppose a particular material fails by ductile fracture, and if you reduce the size of that specimen, and then its impact resistance decreases. And if suppose a particular material fails in a brittle manner or by brittle fracture, if you reduce its size, then its impact resistance increases. Then the third factor is the notch effect. As the dimensions of the notches you are used increasing, okay, that v-shaped notch, u-shaped notch, or keyhole shaped notch, if you increase the depth of that notch, then what will happen? Its impact, it will affect the impact resistance values. It will affect the impact resistance values. If you use the means the sharpness of that notch, or you can say that depth of that notch you are increasing, then automatically it will decrease its impact resistance values. Automatically it will decrease the impact resistance values. Then effect of the temperature. Now the fourth parameter is effect of the temperature, that is shown with the help of this diagram. Here this is the diagram showing the effect of the temperature. At lower temperature conditions, lower temperature conditions, failure of that material will be in brittle manner, and at the higher temperature conditions, failure will be in ductile manner. And this temperature zone, okay, this temperature zone, you can say that the mode of fracture changes. Okay, this is the temperature transition temperature zone, or you can say that transition temperature range. Here mode of fracture is changing from brittle to ductile. That's why this zone is termed as transition temperature zone. In temperature point, you have to just mention that when temperatures are very low, then failure will occur in a brittle manner, and when temperatures are a little bit higher, then failure will occur in a ductile manner. Okay, now here the one point is that one term is there, ductile brittle transition temperature. When a ductile material fails in brittle manner, when a ductile material fails in a brittle manner at lower temperature conditions, that particular temperature will be termed as ductile brittle transition temperature. Okay, this you have to explain. This you have to explain. Okay, in this way, this impact testing is finished. In this, the four very important point will be, first you have to draw the diagram, then you have to explain the Charpy test specimen preparation, Izod test specimen preparation, then what will be the difference between these two test specimen preparations, then how the actual test is conducted, then how the toughness is calculated, and what are the factors affecting the toughness or impact resistance of that particular material. These four parameters you have to explain: velocity of the striker, specimen dimensions, notch effect, and the temperature. And along with that, you have to mention the ductile brittle transition temperature. What is the meaning of the ductile brittle transition temperature? Okay. Now, in this way, we have finished this impact testing here. If you are having any query, you can put that in the chat box. Otherwise, I will stop here. If you are having any query, you can put that in the chat box. Please give me a fast reply. If you are having any query, Okay, in this way, we have finished the tensile test. Tensile testing and impact testing. In next lecture, we will only three tests are left now: hardness testing, fatigue testing, and creep testing. That we will see in the next few lectures. We will conclude that. Okay, for each test, I will take one lecture. In three lectures, uh, we will cover with the 100% syllabus. Now almost 95% syllabus is complete. Only three lectures will be required to finish these remaining three tests. If you are having any questions related to the tensile testing, impact testing, you can ask me. If you are not having any questions, I will stop here. Thank you. Thank you for attending the session.